Good day everyone. For today's topic, we have factors and primes. Factors, even and odd numbers. As what is stated in the previous topic, in 3 times 5 equals 15, 3 and 5 are called factors and 15 is the product. A number may be the product of more than one pair of factors such as 12. 12 has 3 pair of factors such as 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. A natural number that has a factor of 2 is an even number, and a natural number which doesn't have 2 as a factor is an odd number. An example even numbers are 2, 4, 6, 8, 10, 12, etc. An example of odd numbers are 1, 3, 4, 5, 7, 9, and 11. Prime and composite numbers. Prime number, also a prime factor, is one with no other factor except itself and 1. The following numbers are prime: 2, 3, 5, 7, 11, 17, 19, 31, 37, 41, and etc. We have here an examples: 31, 8, 17, and 12. 31 and 17 has one pair of factors, while 8 and 12 has 2 or more pair of factors. Therefore, 31 and 17 are prime numbers because it has no factor except itself and 1, while 8 and 12 are composite numbers because it has other factors except itself and 1. Divisibility. To determine easily the prime factors of any numeral, the student should know from sight whether a numeral is divisible by 2, by 3, by 4, by 5, and etc. The following guides will prove to be very helpful to the student. Numerals divisible by 2. A numeral exactly divisible by 2 if the last digit of the numeral is 0, 2, 4, 6, or 8. Determine which of the following numerals are exactly divisible by 2. Without using paper and pen, we can determine which of the following numerals are exactly divisible by 2 by looking at their last digit. So we encircle a numerals exactly divisible by 2. 8, 14, 20, 32, 16, 46, 36, 110, and 318 are all exactly divisible by 2 because their last digit is 0, 2, 4, 6, or 8. Numerals divisible by 3. A numeral is exactly divisible by 3 if the sum of their digits is divisible by 3. Determine which of the following numerals is exactly divisible by 3. So we're going to add the digits of the numerals and determine the sums if it's divisible by 3. In 324, the sum of the digits is 3 plus 2 plus 4 equals 9. 9 is exactly divisible by 3. Then 324 exactly divisible by 3. 345, the sum of the digits is 3 plus 4 plus 5 equals 12. 12 is exactly divisible by 3. Then 345 is exactly divisible by 3. In 113, the sum of the digits is 1 plus 1 plus 3 equals 5. 5 is not exactly divisible by 3. Then 113 is not exactly divisible by 3. In 405, the sum of the digits is 4 plus 0 plus 5 equals 9. 9 is exactly divisible by 3. Then 405 is exactly divisible by 3. In 432, the sum of the digits is 4 plus 3 plus 2 equals 9. 9 is exactly divisible by 3. Then 432 is exactly divisible by 3. In 447, the sum of the digits is 4 plus 4 plus 7 equals 15. 15 is exactly divisible by 3. Then 447 is exactly divisible by 3. Numerals divisible by 4. A numeral is exactly divisible by 4 if the last two digits of the numeral are divisible by 4. Determine which of the following numerals is exactly divisible by 4. In 308, the last two digits 8 is divisible by 4. So 308 is exactly divisible by 4. In 216, the last two digits 16 is divisible by 4. So 216 is exactly divisible by 4. In 104, the last two digits 4 is divisible by 4. So 104 is exactly divisible by 4. In 313, the last two digits 13 is not divisible by 4. So 313 is not exactly divisible by 4. In 114, the last two digit 14 is not divisible by 4. So 114 is not exactly divisible by 4. In 722, the last two digit 22 is not divisible by 4. So 722 is not exactly divisible by 4. In 412, the last two digit 12 is exactly divisible by 4. So 412 is exactly divisible by 4. In 328, the last two digit 28 is divisible by 4. So 328 is exactly divisible by 4. Numerals divisible by 5. A numeral is exactly divisible by 5 if the last digit is 0 or 5. Determine which of the following numerals are exactly divisible by 5. From sight, we can tell which of the following are exactly divisible by 5. So 210, 305, 115, 320, and 410 are all exactly divisible by 5 because the last digit is 0 or 5, while the remaining numbers are not divisible by 5. Numerals divisible by 6. A numeral is exactly divisible by 6 if it is divisible by 2 and 3. Determine which of the following numerals are exactly divisible by 6. First, we are going to mark which are divisible by 2. Underlined numerals are all divisible by 2 because the last digit are 0, 2, 4, 6, or 8. So next, we are going to determine the numerals exactly divisible by 3. Encircled numerals are all divisible by 3 because the sum of their digits are all divisible by 3. 504, 180, 336, 246, 306, and 702 are divisible by 2 and 3. Therefore, they are exactly divisible by 6. 442 is only divisible by 2, so 442 is not exactly divisible by 6. 603 and 207 are only divisible by 3, so 207 and 603 is not divisible by 6. Numerals divisible by 9. A numeral is exactly divisible by 9 if the sum of the digits is divisible by 9. Determine which of the following numerals are exactly divisible by 9. First, we are going to determine the sum of the digits, and then determine if the sum of the digits are all divisible by 9. So 12, 27, and 9 are all divisible by 9, while 8 is not divisible by 9. Therefore, 435, 9,810, 2,241 are exactly divisible by 9, while 2,330 is not exactly divisible by 9. Numerals divisible by 10. A numeral is exactly divisible by 10 if its last digit is 0. Determine which of the following numerals are exactly divisible by 10. So 20, 240, 100, 200, and 300 are exactly divisible by 10 because its last digit is 0.